NASCAR, an acronym for the National Association for Stock Car Auto Racing, is one of the most popular spectator sports in North America. NASCAR vehicles are modeled after certain American-made four-door passenger cars, but with far more powerful engines. No overhead camshaft engines on this track. For tradition's sake, NASCAR rules require an overhead valve engine, an older type of configuration, also known as a pushrod engine. Designing the engine takes about a year and a half. It culminates in a detailed computer model, an anatomical rendering of the engine in full detail, right down to every last nut and bolt. The computer model guides a stereolithography machine to produce a plastic prototype of each engine component. The machine repeatedly outputs paper-thin layers of photosensitive liquid resin, which an ultraviolet laser instantly solidifies. Over the course of several hours of resin layering, the prototype component takes shape. Technicians test it in conjunction with other prototype components and make any necessary adjustments to the design. Then, computer-controlled machining equipment produces a metal prototype. When every component has gone through this process, the engine design gets the go-ahead to move into production. The factory first casts the basic shape of certain components in a mold, then machines that shape to its final form. Here, computer-guided hones finish the engine's 8-cylinder bores, the chambers in which the power-generating combustion cycles will occur. Technicians take very precise measurements to ensure the bore's diameter and roundness meet specifications. Then they flip the engine block upside down, oil the crankshaft bearings, position the crankshaft on those bearings, and lock it in with bolted-on caps. As the pistons inside the cylinders move up and down, they rotate the crankshaft, driving the clutch and transmission which propel the race car. With this little black component called a wrist pin, they join the piston to a connecting rod. Next, they fit 2 rings on the piston. The top one seals the cylinder, maximizing the pressure inside, which optimizes combustion. The bottom ring skims excess oil off the cylinder walls between combustion cycles, which prevents the car from burning oil. After inserting a piston all the way down into the cylinder bore, they grease the upper portion to prepare for measuring the compression ratio, which must comply with NASCAR rules. The compression ratio refers to the volume of space in which the piston compresses the gas and fuel mixture entering the cylinder. To take this critical measurement, they raise the piston all the way to the top dead center point, then verify the positioning with gauges. They seal the top of the cylinder with a see-through plastic plate. Then with a syringe, inject alcohol into the space in between. The markings on the syringe tell them how many cc's, or cubic centimeters, filling that space requires. This volume measurement indicates the compression ratio. The higher the compression ratio, the more horsepower the engine produces. They repeat this test with each cylinder. They flip the engine block upside down and put each piston's connecting rod in the corresponding position on the crankshaft. Then lock the piston in place with bolted-on connection caps. Now the technician closes up the bottom of the engine. Meanwhile, a device called a profilometer inspects the camshaft. The camshaft moves the intake and exhaust valves at the top of each cylinder, allowing the fuel and air mixture in and the combustion gases out. This testing ensures the camshaft is straight and that its surface is slightly rough, so that lubricating oil will cling to it. The engine build is now about halfway there. In In a pushrod engine, the camshaft is located, as we've just seen, above the crankshaft. It opens and closes the valves with a system of lifters, rods, and rocker arms. In the more modern overhead camshaft configuration, the camshaft sits on top of the cylinders, moving the valves directly. Building the NASCAR engine continues with the installation of this aluminum motor plate, by which mechanics will mount the engine in the car. Next, the timing belt, which links the camshaft to the crankshaft, ensuring they turn in sync and maintain the correct timing. At the core of the belt is a woven material that's 5 times stronger than steel. Other technicians use a gauge to measure how much force it takes to compress the valve springs. This quality control check ensures that spring tension is within a specific range. Each cylinder has an intake valve and an exhaust valve. Technicians use a compression tool to squeeze a spring over each one. Then they secure the spring with a locking clip. The valves are located in the top section of the engine, called the cylinder head, which technicians now bolt onto the engine block. Next, they assemble the pushrod system, by which the camshaft opens and closes the valves. First, rocker stands, then pushrods. These insert into lifters, which connect to the camshaft. And finally, rocker arms. One end of each arm goes on the pushrod, the other sits on the valve. When the camshaft turns, the system opens and closes the valves. Technicians close up the cylinder head with a valve cover. Next, they install the engine cooling system, starting with the water manifold. After mounting a cover to protect the cam belt from rocks and other debris, they install the water pump. It circulates cold water through the engine to prevent overheating. Having absorbed the heat, the water exits the engine via the manifold, then travels to the radiator, which cools it back down. Then the pump, driven by this pulley, sends the water back into the engine to repeat the cycle. Next, technicians mount the alternator. It generates electricity to run the engine and other components, such as the air conditioning, the dashboard gauges, and fans, which cool the brakes, tires, and rear end. This belt drives both the alternator and the water pump pulley. Next, technicians install the oil pump. It sucks hot oil out of the engine, sends it to the oil radiator for cooling, then pumps it back into the engine. Now the distributor. It sends electricity from the alternator-charged car battery to the spark plugs. The spark plugs fire, igniting the fuel and air mixture in each cylinder, producing a mini explosion that drives the piston. This component, the intake manifold, feeds the air and fuel mixture to the cylinder intake valves. The carburetor regulates the mixture ratio by metering the right amount of fuel to the amount of air coming in. Technicians install the numerous parts that make up the clutch. Next, the starter ring, which engages with the starter to fire up the engine. Finally, they mount the bell housing, a cover that protects the clutch from debris and connects the engine to the transmission. The factory hooks up every engine it produces to a testing machine. The machine starts up and runs the motor, analyzing some 300 performance criteria, from revolutions per minute to fuel flow. At the same time, 3 remote-controlled cameras shooting from different angles enable technicians to zoom in and view on a monitor anything they need to visually inspect. All this to ensure the engine they've built will have a winning track record.